Good day. Today, Hansen, Jada, Ariane, and myself will be sharing a bit about an important aspect of animal behavior, which is animal learning. So, to study the behavior in animals, the cross fostering study was performed in which species were removed from their original habitats and they were placed in care of new parents. Similar to this study, the twin study was carried out using humans, and both of these proved that the environment influences animal behavior via learning, which is the modification of their behavior in response to their experiences. Now, while an animal's learning capacity does depend on neural activity, learning is driven by the exposure of conflicts when they experience a change in environment.
Now, when it comes to problem solving, there are more than one type. There is cognition, imprinting, social learning, and spatial learning, as well as associative learning, all which shall be covered as we progress with the video.
So let's talk a bit about imprinting. This is a way in which animals learn how to behave. Imprinting occurs in a really early developmental stage in the young animals. They would observe their mother moving away from them or calling them. Animals that follow and imprint their mother receive more care and learn necessary skills that they would need throughout their life, and therefore they have a greater chance of surviving than those who do not imprint. Imprinting is not permanent, so this only occurs in a certain stage of their life. Imprinting was suggested by Conrad Lawrence, who was an Australian scientist, and he was the first one who noticed this in 1935.
Associative learning is the acquired ability to associate one environmental feature with another, with a condition that lets one thing predict another thing based on past experiences. Now, there are two types of associative learning. There's operant conditioning, also referred to as trial and error or instrumental conditioning, and classical conditioning, also referred to as Pavlovian conditioning. It's based off the man who created it, or invented it rather, named Ivan Pavlov. Operant conditioning is a learning process wherein rewards or punishments are used in order to reinforce a certain behavior. Classical conditioning is a learning process wherein two stimuli are continually reinforced with one another until it reaches the point wherein the first stimulus will elicit the same reaction as the second stimulus. But let's look at some examples to show you what I mean. Moving on to examples of classical conditioning and operant conditioning, I'll be going over briefly what each are. So for classical conditioning, it's usually when the dog salivates over the arrival of his food. The food would be the unconditioned stimulus, and the dog that salivates would be the unconditioned response. If you were to introduce a bell with a sound or some tone of some sort, that would be the neutral stimulus, as you can see in the pictures. Normally at first this would mean nothing to the dog, right? But if this bell or this tone were to be played continuously every time before the arrival of his food, he would associate that tone with the arrival of his food. So now that tone has become the conditioned stimulus. So now every time that bell is rung, he would salivate because he would associate it with the arrival of his food. So originally the dog would only salivate on the arrival of his food, but now he salivates over the sound of this tone, and that is what classical conditioning is. Moving on to operant conditioning, I've decided to use a blue jay, also referred to as the Cyanocera cristata, that ingests a brightly colored monarch butterfly. As you can see in the picture, it's eating it. That butterfly is also referred to as the Danus plexippus, but substances that monarch accumulates from milkweed plants cause the blue jay to vomit almost immediately, and because of that experience that it just went through, in the future when it sees another monarch or a butterfly that shares similar characteristics, that looks similar looking, it would try to avoid it and it would not attack it anymore. It is the ability to associate one environmental feature, such as the color of that monarch, with another, such as a foul taste. So now when it sees such colored butterflies with that specific pattern, it would associate it with a foul odor, avoiding it completely, and that is operant conditioning.
Spatial learning refers to the process by which an organism acquires a mental representation of its environment. Spatial learning has been found in both vertebrate and invertebrate species. One of the major problems many animals must confront is how to find their way around their world. For example, to know where a particular resource is and how to get it from their present location, or what is a safe route home to avoid a predator. Such spatial learning may cover only the highly restricted confines of an animal's own range or territory, or it may embrace a migration route of several hundreds or even thousands of miles. In the laboratory, the primary method of studying spatial learning has been to put a rat in a maze and observe how it finds its way to the goal box where it is fed. A rat placed at the end of one arm must run to the central choice point from where it has to enter one of the two remaining arms. Although extremely simple, even this apparatus allows for a number of possible modes of solution. One possibility is that the rat learns to execute a particular response, a left turn or a right turn at the choice point, because that response is followed by food. A second possible solution is that the rat learns that the two alternative arms differ in some particular way and further learns to associate one of the arms with food and hence choose it. The third and most interesting possibility is that the rat learns to define the rewarded arm not in terms of its own intrinsic characteristics, but by its spatial relationship to an array of landmarks outside the maze. Thus, the rat might learn that the correct arm is the one pointing to the left of a window away from a table with a lamp on it. Experiments show that whenever such landmarks are available, this third solution mode is the one used. An animal can move around its environment using landmarks alone. Honeybees, for example, might learn 10 or so landmarks and locate their hives and flowers in relation to those features. An even more powerful mechanism is a cognitive map, or an internal representation or code of the spatial relationships among objects in an animal's surroundings. It's actually very difficult to distinguish experimentally between an animal that is simply using landmarks and one that is a true cognitive map. The best evidence for cognitive maps comes from research on the family of birds that includes jays, crows, and nutcrackers. Many of these birds had food in caches. A single bird may store nuts in thousands of caches that may be widely dispersed. The bird not only finds its cache, but also keeps track of food quality, bypassing caches in a way that food was relatively perishable and would have decayed. It would seem that these birds use cognitive maps to memorize the locations of their food stores.
On to social learning, it is the modification of behavior through the observation of other individuals. What I have presented before you is a vervet monkey. So what vervet monkeys do is they have this thing called alarm calls. Alarm calls basically indicate a predator to other vervet monkeys, and it tells them to take the necessary precautions. So as you can see, there are alarm calls for eagles, leopards, and snakes. When it's an eagle, they run to bushes. When it's a leopard, they climb on trees. When it's a snake, they stand upright and look down. Younger vervet monkeys tend to mimic what they see their parents doing. Of course, they're young, so their alarm calls may not be as completely accurate. They might signal eagle alarm when it's a snake. So the other adult monkeys don't take it too seriously until the other parents do so. Only when the vervet monkey starts having accurate calls will it be taken seriously. And that is one example of social learning. And the last example is chimpanzees. And here we have a picture of a young chimpanzee learning to crack oil palm nuts by observing another monkey do so. By so, it now learns how to do it by himself. And that is social learning.
Lastly, we have cognition and problem solving, which is the most complex form of learning because it does involve reasoning. And as we know, animals don't have the capacity for higher level reasoning like us humans. However, they do go about making decisions by sensing the environment and the available information. For example, we have here a species of raven that were exposed to a conflict when their food was hung on a string instead of being left on the ground for them, and upon failing to get their food, one of the birds flew up to it and grasped it immediately, while another just flew to the branch and pulled on the string until it was able to get the food. And this scenario here shows how the birds sensed the environment and somehow came up with ways to get their food simultaneously, indicating that they do possess cognition for problem solving.